7.4, using metaclasses. We're going to take a look at what metaclasses are, how they relate to class decorators and to classes themselves. We're going to see how to use the metaclass to change the way the class namespace works. And we're going to see about adding inheritable special behavior to classes. Like class decorators, metaclasses are a tool we can use to adjust the basic meaning of a class. In concept, though, they're very different. A class decorator takes an already created class and transforms it in some way. A metaclass, on the other hand, can affect how a class is created, how it behaves, and even how classes that inherit from it are created and behave. To understand metaclasses, we first have to grasp the idea that classes are objects, and more than that, they are instances of another class called type. Anytime we create a new class, we're creating an instance of type, unless that class has a metaclass. If the class we're creating has a metaclass specified, or it inherits a metaclass from its ancestors, then the new class is an instance of the metaclass, rather than being an instance of type. That sounds like we could change the behavior of a class completely by giving it an unusual metaclass. But actually all metaclasses have to resemble type, or Python wouldn't be able to use them properly. Most of the time, metaclasses are actually subclasses of type, which makes things simple. Alright, so what can we do with a metaclass? First of all, we can run code before the code inside the class block is evaluated for each class which is an instance of the metaclass. We do this by giving the metaclass a prepare method in double underbars, which should be either a class method or a static method because it will be called before the instance is created. The prepare method is passed the name of the new class and a list of parent classes, as well as any keyword arguments supplied by the user. The prepare method can do whatever it wants, but it should also return a dictionary or similar object that can be used to hold the class's attributes while it's being evaluated. We can pre-assign values into the attribute dictionary from inside prepare, so we can actually assign attributes to the class before it even exists. That brings us to the second thing metaclasses can easily control: class's namespace. In the first example, we returned a dict instance from prepare. So instances of this metaclass, the basic metaclass on the screen, use a normal dictionary to store the attributes while their code is being evaluated. But we can return any dictionary-like object from prepare. For example, we could return an ordered dict if we wanted to keep track of the order in which attributes are created, as is done with the ordered meta class on screen, or a default dict if we wanted all attributes to have a default value. We could even use a weak value dictionary if for some reason we wanted the class to not protect its attributes from being garbage collected while it was being evaluated. Offhand, I can't think of any use for that, but it's possible. Of course, those are just dictionary-like classes that exist in the standard library. We could also use a custom dictionary-like class, which would conceivably do almost anything. If we want a class that ignores the case of attribute names while its code is being evaluated, we can do that. There's a reason I keep saying while the code is being evaluated. After prepare is called, the code inside the class block is run, and it uses the dictionary that was returned from prepare as its namespace. But after that, the metaclass's new method is called. One of the things new needs to do is call type.new to actually allocate and initialize a chunk of memory to contain the class data. And one of the things that type.new does is convert whatever we pass it as the namespace into an actual straightforward Python dictionary. That means that if we want to retain special information that our namespace object knows, we need to store it somewhere later where we can find it, as is done with the register descendants metaclass and the ordered metaclass in the examples on screen. We can make whatever changes we want to the internals of the class once we've created the object using the new method of the metaclass. We can programmatically add, remove, replace, wrap, and otherwise manipulate the contents just as we could with the class decorator. We can also return something that isn't actually a class object at all, again just as we could with a class decorator. The difference, aside from a bit of extra typing, is that the subclasses of a class that has a metaclass will also inherit that metaclass, while class decorators are not inherited. That means that, using a metaclass, we can make our unusual behaviors inheritable. The register descendants example makes it so that any class that descends from the class where the metaclass was originally applied can find all the other classes that also descend from that ancestor, including the ancestor itself. For example, here we have the metaclass applied to the quadruped class. Horse and dog are both descendants of quadruped. And as you can see, they've inherited the special behavior of the register descendants metaclass, giving them access to the registry attribute, which contains a set of all of the classes descended from quadruped. So classes are instances of metaclasses, which is not the same thing as inheriting from a parent class. Normal classes are instances of a metaclass called type. We can specify a metaclass alongside a class's parents by using the metaclass keyword argument of class parameter list. Metaclasses usually do their work in the new and prepare methods, prepare being an optional method. Subclasses inherit their parent's metaclass, so special behavior defined by a metaclass is inherited. We're done talking about metaclasses, so let's move on to the next topic, context managers.